We are joined today by folks from 3 companies doing stuff that I think is really interesting, and I'm really happy to have them talking about it tonight. Speechmatics and Tavus and OpenAI. But first, if you've been to one of these things, you have to hear me talk for just a couple of minutes. I'm going to try to sort of set the stage, paint a little picture of the through line for the 3 fireside chats we're going to do. The theme tonight is benchmarks. I'm Quinn. I work at a company called Daily. We make infrastructure for real-time audio, video, and AI, and I work a lot on an open source project called PipeCat, which is the most widely used framework for building things like voice agents. And one of the really fun things about working with PipeCat is that I get to collaborate with everybody at all layers of the stack and talk to lots of different people. And for a couple of years, I've been grumbling to everybody, including lots of people in this room, about how bad a lot of the public benchmarks are and how I have tools that I've built internally that are so great. And people said, well, if that's true, why don't you make those tools public and stop complaining? So for the last couple of months, I've been working on cleaning up code that I use and trying to make good public benchmarks, which is hard. So we're going to talk about benchmarks tonight. Released about a month ago some code that started life as the evals framework for a voice assistant we built for the AI Engineer World's Fair last year. And we were using a pre-release version of Gemini 2.5 native audio, and it was amazing and also terrible. And we were trying to figure out why and how. So we built a bunch of sort of long conversation audio eval stuff that we could run over and over and try to fix some stuff in the API and fix some stuff in PipeCat and figure out what it was doing. The thing I tried to do in this benchmark was really reflect real world things we all do with voice agents. And to me, that means long conversations. So this benchmark has 30 turns, complex instruction following, and a big system prompt, because most of us end up shoving a lot of stuff into a system prompt, for better or worse, and real function calling. And if you've built a lot of voice agent stuff, function calling is absolutely critical for most workflows we do, and also it's a weakness of today's models, even the very best ones, when you get pretty far into multi-turn conversations. So that was the point of this benchmark. And then we worked with a bunch of people to build a speech-to-text model benchmark using exactly the code patterns we see people using over and over and over again in enterprise use cases with PipeCat. We're going to talk a lot more about this one soon. To me, the most exciting thing that came out of this was there's a really clear Pareto frontier here for these speech-to-text models, at least the way we test them. And we'll talk about how every benchmark is really just one data point, and you should take them all with a grain of salt. But you can see that there are 3 speech-to-text models that have a cluster of latency and low word error rate. And there's a pretty big delta between them and the others, at least on this one benchmark. And we want to dig into that a little bit with the folks from Speechmatics, who are one of those 3 models. The other thing we did with this benchmark was we didn't use a standard word error rate measure, because LLMs are not exactly like people, or not exactly like spitting out text to print it on the printed page or on the computer monitor. We'll talk about that too with the Speechmatics folks. So the 3 things I think are really important in public benchmarks, no matter what you're doing, are that they reflect real world use cases, that you try really hard to make them as fair as possible, which involves making a lot of pretty tough judgment calls. And that's a thread I want to pull on tonight. And to do that, you have to look at so many outputs, so many runs. This is a machine learning theme we all, I think, learn at some point. It's all about the data. To do anything, you just look at a ton of data, and then you look at more data, and then you look at even more data. And writing good benchmarks is like that. You run the benchmarks, you look at the data, you find where you made a mistake in the benchmark code, or where your assumptions don't quite line up, or where you learned something from running a second or a third or a fourth model against the same benchmark, and then you iterate. Finally, I just want to close with a teaser of a benchmark I hope to release next week. The single most fun thing for me about these conversations we all have when we get together and we're all trying to figure out how to build this stuff that's also new is hearing somebody talk about some new abstraction or new development technique or new way of using a model and thinking, oh yeah, everybody's going to be doing that 6 months from now. And I've been trying to figure out a small slice of that myself over the last couple of months, which I'd characterize as intermixing structured data inputs to a model alongside user text and voice input. It's something that unlocks a lot of possibilities for new use cases for voice AI. We're doing it a lot in enterprise voice AI use cases now, but nobody has great patterns for it. So I've been trying to figure out what those patterns are. I'll give you just sort of a super simple example. Imagine you're writing a personal assistant native iPhone app, and you want to give that app access to the GPS coordinates from the device with the user's permission. How do you feed those GPS coordinates into the conversation stream? Is it a tool call? Is it a lot of tool calls? Is it something you smuggle into the user messages? So I've been writing a lot of code that tries to figure out how to do that stuff. As some of you know, I have a side project that's gotten out of hand, which is a big multiplayer LLM-powered game. So I just took a bunch of the game code and I'm making benchmarks out of it. And the fun thing about writing benchmarks this way is I already have a visualizer for running the benchmarks live. So this is a little teaser of a new sort of structured data input benchmark that I hope to clean up enough to release next week. And a teaser for the game, which we're finally gonna put up and hopefully everybody will play and make better because it's all open source. So if you're subscribed here, you get an email with like early access to the game because I want everybody to try to figure this stuff out with us. And without further, this is like the table from the benchmark, including a pre-release EA early access secret model that I'm not allowed to talk about yet at the very bottom. So much more fun stuff coming next week. So without further ado, Ricardo, Sam, can we talk about benchmarks? There's a mic over there. You guys are friends. I'll let you share the mic. So please introduce yourself. Tell the folks what you work on. It will play the video, and then we'll talk a little.
Thanks. Hi, my name is Ricardo, so I'm one of the founders and the Chief Strategy and Revenue Officer at Speechmatics. So Speechmatics was my first company, only company, still is. We could go a long way with it. We founded it out of Cambridge back in 2014. We do speech to text, as you saw, the most accurate model on Quint's benchmark, which is great. We're going to be shifting that latency further to the left as well. And it's just excited to essentially become a little bit less English about things and really sort of push the presence a bit further here in the Bay Area, because we don't tend to shout about stuff enough. I'll pass over to Sam quickly to introduce. I'm actually stuck between two Sams at the moment, and you'll be able to tell based on how the slightly smaller Sam next to me, how old this demo is and how far we've come since then, but it's still doing some fun stuff. So I'll pass it to you.
Thanks, Ricardo. I'm Sam. I've been at Speechmatics for a couple of years now to help transition from our traditional doing real-time captioning for live broadcast to adapting for voice AI. So I've been working with people like Quinn to try and get our speech-to-text into as many platforms and integrations as possible. And I push and squeeze our technology in ways that it wasn't designed so that we can make it better. And it's events like this and talking to people like you where we learn so much. So it's fantastic to see so many people here. And also thank you again to Tavus. And this is just an office that I could dream of. All these computers, fantastic.
Sam makes great demos in addition to writing lots of good low-level code. So I'm going to play a quick video of one of Sam's demos.
Should we say this first?
Yeah. Intro.
Yeah, so just in this demo, and again, this is old. So like the latency since this demo has more than halved. But just so you're aware, what we're showing here is sort of our ability to use diarization within the real-time models. So it's able to work out who a speaker is. And you can use this for tons of different things. You can get it to focus on a certain voice, you ignore other people, you can get it to remember you next time you talk to it, and you can get it to not allow other people to do certain things. So I did want to do a live demo, and I was very excited to do a live demo.
I don't allow people to do live demos, it's my fault.
But we can show you one later on if once this is over.
Okay, we're going to do a very quick demo of ESP32 and PipeCat, and we're going to have a game of Guess Who using Speechmatics ASR. So let's just give this a start. Okay, I'm Sam.
And I'm Matt.
Great. Thank you, Sam and Matt. That gives us 3 players. Would either of you like to be the responder, or shall I think of someone for you to guess?
Yeah, why don't you think of somebody, maybe if you can think of somebody British.
Not too hard.
Not too hard.
All right. I will think of a British person who is not too difficult to guess. I have someone in mind. Now, who would like to go first with a yes or no question? Sam or Matt?
I can go first.
Thank you, Matt. You will go first, then Sam will follow.
Sure
Matt,
thing.
you may ask your first yes or no question.
Okay, are you currently alive?
No.
Were you a politician?
Were you an entertainer?
Yes.
Were you in literature?
No.
Dang. Were you a scientist?
No.
Were you in film?
Yes.
Okay, a British film person. Were you alive in the 1900s? Okay.
I have already answered your question about being alive. Please wait for your turn. Sam is next. Thank you, Matt.
Were you in black and white films?
Yes.
My British trivia is not so good. You know what? I pass. I don't know.
Oh,
You got.
okay. I reckon it's Charlie Chaplin.
Yes, you are correct, sir. The person I was thinking of is Charlie Chaplin. You have won the game. Well done. Would you like to play another round or finish here?
No, that's super. Well done.
Well done. I didn't know he was British.
Yeah. So there you have it. So using Speechmatics, the assistant is able to know who is speaking, and it makes guess who work.
Yeah. Turns and everything. My goodness.
Yeah.
So we'll talk about diarization in a minute, but speaking of British people, we worked together on this benchmark. And I think in my American way, I'll say I think we had a really productive and frank exchange of ideas. Just between us, nobody else listening, you can drop the really charming British, reserve and tell me how terrible was it working with us on this benchmark.
Long nights. It was something. I mean, you're going to talk a little bit more about latency, I know. For us, there was this challenge of how low can we go without compromising what we want to deliver. And as I mentioned earlier, I push and squeeze our technology in ways that we hadn't really been pushing and squeezing it before. And we were able to make some big, leaps in that time. So it was a great opportunity for us to show that we can compete on that scale.
Well, one of the things I thought was interesting about pulling other people into a project like this is I feel like we talk about latency all the time. Those of us working at the application layer of voice AI. It's like a drinking game where anytime I say latency, if you took a drink, you would not be, on your feet ever, all day, every day. But when we actually worked with you on trying to put numbers against specific performance scenarios, not like a general conversation about latency, it really did change the conversation we had.
Yeah, I mean, the bit that's always the challenge is, we've all got friends who interrupt. You haven't quite finished what you're saying, and just wait for me to finish. I'm probably a bit more polite than that. So we were having to look at things in a different way, and obviously you've got a fantastic smart turn model, which is able to help acoustically look at whether somebody's finished speaking. So we can now take a lot of other inputs that mean that we can deliver a much higher performance. But yeah, it's that benchmark. I mean, it's a little bit like that Volkswagen shenanigans where, the cars, when they were being tested, they were going into a special mode. It sort of feels like with benchmarks that you're having to go into a very special mode, but actually the reality is that in a conversation, 200 milliseconds against 400 milliseconds. The 400 milliseconds is going to make a slightly better and less interrupted conversation. So we've really enjoyed, as I say, pushing and getting ourselves down.
No, I mean, I think this is exactly the kind of thing we talked about when we were working on this, which is, what are we aiming for? What is the goal? Is the goal the fastest possible transcription, or the highest possible accuracy, or some mix of those two? And then how do you actually measure them in a real world scenario in a way that actually matters for the application, not some arbitrary number? We talked a little bit about word error rate. Like yesterday when we were hanging out, you told me a funny story about one of your folks who had some criticisms of the word error rate measure we had.
Yeah, we actually have a whole Confluence page together of criticisms of Pipecat's benchmarking, which has a lot of contributions from most.
You're not the only ones.
But that's right. Just to take a step out there, it is great to sort of have an independent benchmark, especially that works in real time, because so much speech-to-text benchmarking is sort of for asynchronous. It's much easier to test. So to have this in real time is awesome. We've got lots of feedback for you on how you can make the tests more difficult, more real world. But we're delighted where it sits as a start. But yeah, sort of one of our interns came in. It was a precocious chap, and he decided to write a blog post on the benchmark. He's been in the business about 2 months. And sort of went through it all, and then it's like and talked about the different types of latency, and then he got onto sort of turn latency, or as you call it, time to final segment. Time to final segment, however, not in the code. In the code, it's time to first byte, which is already a bugbear for us, because time to first byte on some evaluations can just be. You can essentially work around it to just get the speech-to-text engine to output the word to, or whatever. So even if the word is incorrect, it will show that you're responding very quickly, but time to the first incorrect random word isn't helpful at all. So there's a few feedback bits that we'd like to improve on, but we are generally very happy with it. And I won't actually let you see the Confluence page. But yeah, or Archie if he ever comes over here.
I mean, everybody who builds systems has different trade-offs in mind. And trying to find a way to triangulate between all those trade-offs in a way that is useful for everybody involved, I think is super interesting and super fun. The time to first byte thing is because in Pipecat, there's a standard metrics frame, and that metrics frame was originally built for text to speech. So we cared about time to first byte. And LLMs have time to first token, and ASR models have something much more complicated and actually harder to pin down, but we like a measure which we arbitrarily call time to final segment. Funny thing about time to first byte, we were measuring time to first byte for quite a long time before we figured out that text-to-speech models always pre-roll silence, and a lot of silence. That number has gone down in the last 6 months. I think it's because we started publishing the pre-roll numbers in our benchmarks for text-to-speech models. We were seeing text-to-speech models pre-roll 600 milliseconds of silence, which, if we're aiming for 1200 milliseconds, voice-to-voice, including network transport, that's a lot of your budget. So measuring things really does matter. Let's talk about diarization, because I think you guys are, I have said to you, I think you are trying to solve a chicken and egg problem, where you have this amazing technology that can do this really cool thing that we saw in the demo that opens up new use cases. Some of us building applications are like way behind you, and we're still trying to, make simpler use cases work. Tell us how you got so interested in diarization and what you think we should all be doing with it.
So the interest in diarization came primarily actually from like a different use case. So the area where we cut our teeth in this industry is in the live captioning space. So we used to think our real-time latency was really good, because in live captioning, you want to give enough context to make sure the word is absolutely right. There's no LLM involved correcting things. And for that, we'd recommend have a final by 1.5 seconds, 1500 milliseconds. Obviously in voice AI, that doesn't cut it, but we're like, oh, we're great on this sort of accuracy latency curve. And then we got into the voice AI space, like, oops, maybe not. But for that, obviously you're getting these, you're transcribing TV. There's no multiple channel one side or the other. You have to get highly accurate diarization for all of those different use cases. And so we'd already built them. That diarization model was built on the self-supervised models that we'd also used to build our speech text itself. So getting it to learn different representations and just seeing what the body would output. And it just meant that we ended up in a very good space there. We built our models to be real-time first. And so we've got this great diarization model that people actually come to us to try and buy now separately from the speech to text, which we're trying to avoid, that we productize something else. But obviously it does give you like a whole berth of different use cases in the sort of the agentic space. The one that we've definitely seen the most use for is that you are talking to an agent in a public place with your AirPods in, which again, noisier audio, more difficult for benchmarking, hint, hint. But certainly sort of being able to have the diarization and just somebody calls, the first voice you hear, locking onto that voice, not listening to any others, avoiding any sort of interruption makes a massive difference. There's a world which you can start to trend towards the idea of sort of authentication as well, but it's a bit funky in there where you save the voices, but there are myriad use cases you can use that for. If you have anything.
Yeah, I was just going to add that some of the customers we've been talking to, for example, in the banking sector, when you are talking to an agent and suddenly there is a third person's voice detected, then legally there has to be a question as to who is that, who's on the call, etc. So diarization will start to become an issue as more and more banking sector and businesses start to use agents. The struggle in inverted commas, and you sort of referred to it as a chicken and egg situation, is because there's only a small handful of us that do diarization, it's not been a priority for different platforms such as Pipecat to cater all the way through the pipeline for Sam said these words, Quinn said these words, etc. So once diarization starts to become more part of a conversation, then it will hopefully make the use of diarization become more widespread. But I love it, and there is another video that if people want to see, they can see later of where. Oh, we can do a live demo as well, but I was just going to talk about a video.
So come find these guys. They're
Yeah.
super fun to talk to about this stuff, as you can tell.
Yeah.
Welcome to San Francisco. We hope we see more of you here. We love what you do. We love startup founders here. So come back and see us again. Thank you.
Thank you.
We're playing Hassan is around to talk about Tavus. Yeah. Diarization is such a good segue to you because I think of what you do as so full stack. You guys train models and you sweat every single pixel and every disfluency and fluency of the voice layer. But before we dig in, introduce yourself, talk about Tavus, tell us what you work on.
Yeah, thanks so much for having us. It was our own office, but thanks for hosting this. I'm Hassan, I'm the co-founder and CEO here at Tavus. And Tavus, in a nutshell, is a research lab focused on what we call human computing. So teaching machines the art of how to be human. We want to deliver a future where using a machine feels just like talking to a friend or coworker, where you can just talk to them face to face. And it looks, sounds, feels human. So that's what we do.
I mean, I've known you a while. Like many parts of the AI world we live in, the progress you've made in a short period of time, from stuff that was genuinely impressive the first time I saw it to stuff that now passes the Turing test, is on the other side of the uncanny valley, is incredible. I assume that you have a lot of eval and benchmarking approaches internally because you train a bunch of different kinds of models. Can you talk about like all the different models you guys train and how you think about benchmarking them, and then how you think about them as an ensemble system and not individual models?
Totally, yeah. I mean, so we train right now publicly 3 models: a conversational flow model, so like a turn-taking model, a perception model, so that it can detect like emotional understanding, it can see the world around you, and then a rendering model to actually look human. And so, it's interesting because like I think that what we're trying to do is much an art as with the science. And so, we have specific benchmarks for each model, right? So like for the turn-taking model, for the rendering model, like, a benchmark might be something like lip sync accuracy. So you like read the lips back and see like how accurate was it. You might look at like facial expression accuracy. Like, can you actually detect the facial expression? Was it accurate to an emotion that you inputted? And same thing on like perception. Like, you know, if you throw in examples, did it see the things that you wanted it to see, right? And you can sort of measure that on some sort of loss. But interestingly enough, like I think that what we find is that like these certainly matter whenever we're training these models, but as it comes together, it ends up being way more of an art. It's like we have to have people just have conversations with them, and they'll notice things, and they'll be like, you know, okay, like for example, like, oh, this is really fast, but you know, the way that they're saying this isn't that natural. Oh, like, you know, it's, you know, the lip sync is great, but like, you know, like I feel it's not like expressing that well, right? Like it ends up being a lot of art and nuance. That's much harder to like consistently measure. It's a lot more subjective.
I'm gonna poke at that a little bit though, because I feel like I know what you mean. Like I spend many hours a day talking to voice and video agents, and I feel like there are things I know that I only know because I spend all those hours experientially. But that doesn't really help me when I'm training a model.
Yeah.
So how do you translate that
Yeah.
into?
That's a good question. Yeah, I mean, yeah. So I think that whenever we're training specific models, you know, I think that like on like a conversational flow model, we actually use like we use the evals for some of these things for turn taking to like we'll put in a large data set. We'll say, okay, like, you know, did this model actually properly give the term it was supposed to? Did it not give the term it was supposed to? And so we have a lot of very like quantitative metrics for those things. But you know, I think that when we think about it as like a whole, a lot of things we think about is like, okay, like what was the end-to-end latency? Like, you know, how quickly did it respond back? Like, you know, and so like we see that these pieces sort of add on to that. But yeah, I guess like a lot of times whenever we're measuring this, it ends up being like, okay, yeah, we know that this model is really accurate, but like as a whole, how did it affect this like system can be a lot more subjective than maybe we'd like sometimes. Yeah.
I mean, my personal experience is that all that experiential stuff, you have to figure out a way to turn it into, okay, what's the gap in the training data sets?
Yes, exactly. Yeah.
And that's the leap, and that's hard. I will say, you know, we work with lots of people training models, and every once in a while, I'm having a conversation with somebody who is on the model training team, and I tell them something, and they'll say something completely different, and I'll be like, have you used your own model? And I think it's true that we all live in a little silo.
Yeah.
And it's very hard to get out of that silo. I mean, I certainly have sort of professional deformation from just thinking about the application framework layer all the time and not spending all that time down in the weeds of models, which is one reason why we started training the open source smart turn model, because I thought it was important to kind of work at that full stack. Do your engineers both train models and build at the application layer, or do they train different models, or how specialized is the team?
Yeah, I would say like one of the things that we care a lot about is like this like concept of like being very vertically integrated. The same people that are training the models are the ones that are implementing the models, are the ones that are building around them. Because like that tight coupling sort of is a difference between something just being like on paper good and in reality being a great experience. And I think that's been really important for us is like, you know, the reason that we've built some of these models, like, you know, if there was a really great perception model out there, then we would just use that, because like it's not like we're a massive company, we're not Google DeepMind here. But it's typically been that, hey, like we've tried to do something in that, like we reached for something that didn't exist and we went and built it. And I think that then whenever you build these things, you can really tightly couple them together. So like instead of operating in like text space, you can operate in embedding space. And so a lot of what we think about is like, how can we actually remove some of these layers and make this feel more like a system rather than like individual parts talking to each other?
No, that makes sense. And I think in a lot of ways, I think we're going to see more and more people trying to glue, not just glue different models together, but operate much more at the embedding layer and use other techniques to tie stuff together more deeply. And you guys are very much pioneering in that. What do you see at the application layer that really drives your work these days? Like what is sort of pushing your thinking and your vibes-based analysis of what should be possible?
Yeah, that's a good question. I mean, so you talked a little bit about like passing the Turing test. Now, like, I don't think that we passed the, like, we have an internal benchmark of like the Tavus Turing test, which is like, hey, like, if you didn't tell anyone that this was an AI that you're talking to, would they know? And I think on the audio side, like, I think on speech side, like, I think we passed it. Like, people cannot tell. We're there. On the video side, there's just so much richness in being on a video call with someone. It's like how they move their eyebrow and how they responded to it, and how they reacted to you. And so a lot of what we think about is like, how do we get closer to passing the Turing test? And so you talked about like data, like a lot of what we think about is like, okay, like what's the data that we need to do this? And one of the special things we do at Tavus is we specifically train on two-way conversational video data. So it's like video call, like that. That's what we're training on, so that we can not only understand how humans behave when they're talking, but how they actually behave in a conversation. How do they react to something you said? So, you know, I say something, how does Quinn react to it? And what was the context in which I heard? What's the relationship between his head nods and all those things? And I think that's a lot of fun and quite difficult. But that's sort of what we're thinking about, is always like this like concept like the time to immersion. Like, how long does the version stay alive? How long does it take? Like, those are things that we think about a lot.
Fun and difficult is a good closer. Thank you so much.
Of course, thanks for having me.
We will bring Bo up to talk about audio Turing tests. So one of the things I think we don't talk enough about is that we have blown by the audio Turing test, in my opinion. And when I was in grad school, we almost didn't talk about the Turing test because it seemed so impossibly far away, impossible to achieve. I mean, I was in grad school a long time ago, but let's just say it's within living memory. So this amount of progress is incredible. And that's my intro for you to intro yourself and talk about what you work on.
Yeah, thank you for hosting me. It's a very nice place, and thanks for everyone coming. I'm Bo. I'm working in OpenAI on the GPT real-time model. So just on Monday we released the GPT real-time 1.5, and also last year I worked on the first GPT real-time public released model, and also have a mini series for a faster and cheaper cost. Yeah, that's
So the model you lead, it was the first publicly released production quality speech-to-speech model. So I think that implies a bunch of things about architecture, a bunch of things about model training that you're aiming for. How do you think when you're, say, preparing for the 1.5 release, like congratulations, we all know how big a deal it is to do a big release. So thank you for coming that same week. How do you think about evaluating and making trade-offs when you're going from, you know, the previous release to a big like 1.5 release like you did this week?
Yeah, sure. So I think there are two kind of high-level aspects we care about. One is intelligence, which is consists of function calling, instruction calling, and how the model is able to handle very complicated tasks. And the other part is kind of audio itself. Whether the audio quality is good, is just kind of a clean, does it have noise, or and also does it sound natural? Does it kind of can speak in the correct accent? And how does it handle multilingual? That's actually a really tricky part. So in general, on the intelligence front, we really want to really push to get as much as close as the text model, the best text model as possible. And then also the relatively easier to evaluate because you have kind of a ground truth in that sense, where you have the expected behavior for whether did you call the function correctly, did you actually follow the instructions. So that part is relatively easier. On the audio side itself, that's a bit trickier. So we have some simple ones to try to flag any egregious errors. But on the general, we also probably have to rely on the light to see how the model sounds. Yeah, so that's been kind of a still not fully automated. This is kind of a part where we have to maybe sometimes you have to how do you pick the best checkpoint that balance the intelligence and also the audio quality.
I mean, text to speech and speech output of speech to speech model benchmarks are very hard. I don't think anybody's solved it. We do a lot of data collection for model training, and we use human labelers to say, did it sound good? Did it have these attributes and rubrics? It would be great to be able to automate that. Do you have any internal tools you can talk about that are quantitative and not just fact-based for the speech?
I think for now we're still we're happy with our vibes, but we are still trying to make it kind of automated.
I mean,
it's exactly a research problem.
one of the things you and I talked about earlier today was there's so much variation in human judgment about things like what a voice sounds like, or how long you should pause in a turn detection situation, or how you should react to the other person in the conversation. How do you think about training a model that can please everybody?
Yeah, I guess it's hard to please everybody. It's kind of a subjective, right? So I guess we can flip the view and how do we train a model that's kind of does not make egregious errors. For some errors, it's very easy for everybody to recognize that it should not do this. So for example, if you usually interrupt the model just keeps saying and you're not responding for several minutes, several seconds. So that's definitely bad, right? Or if the user if the user says very kind of a short word or short answer, the model doesn't catch that. Those are obvious bad. So I think we can try to at least measure all these obviously bad cases, and then between the obvious bad and the reasonable one, there's a wide range of distribution of possible kind of allowed behavior. For example, sometimes maybe the latency. From the turn to turn, maybe the higher latency is okay because it's maybe natural for people to respond a bit slower. Maybe the question is harder, it needs time to think. Sometimes maybe it's okay to actually interrupt people maybe or with some action on it. So there's a lot of, I think there's a range of distribution where it's acceptable. So probably no need to really pick out what's the precise best kind of a target, but then we can try to flag all this obviously wrong behavior.
There is still a gap, at least on my benchmarks, between what you called intelligence of the best speech-to-speech models today and the best models operating in text-only mode. I'm sure you can't talk about everything that's in progress, but can you talk a little bit from your perspective training the model about why that's true and about whether we'll see that gap close this year?
Yeah, so I guess one thing may be kind of operational in the sense that there's just more people working on text models and fewer people working on audio models. And then actually one of the upgrade for the GPT Real Time 1.5 is actually we are using the sort of a GPT-5 base. Previously we are using the full O base. So that's why there's a boost in intelligence on the base model itself. Again, because there's so many people working on text models, so that's why it's progressing faster. So I think internally we want to kind of unify these two models a bit more, kind of sharing as much as possible, so that we can kind of get a free win from the text model improvement.
I mean, I will say that as someone who obsessively evaluates these models, it's a little bit unfair probably to put it the way I did, because as the text models have gotten smarter, in general, they've gotten slower, which is the opposite direction from what those of us in the voice AI space would like. And whenever I talk to people at the foundation labs, I'm always like, no, you need to do a post-training run that's just for us. That's like fast, because I don't care whether your reasoning mode is great for a big subset of stuff I do. I just want a better answer than your previous generation model, faster. I assume some of this is just the incredible growth of use, and it's hard to run these massive supercomputers, and you're sharing across everybody else. But I assume some of it is also architecture choices on the text model side that really prioritized working on things like reasoning and didn't prioritize things like latency as much.
Yeah, I think these are changing in the sense that I think the new models are probably more adaptive. So for simple questions, simple tasks can be finished very quickly with very little reasoning. For more difficult ones, more kind of a task that need to be careful, so the model can think longer. So I think this is what the text model already trying to do. I think for voice model, we can also try to push this human direction. It also makes sense, for example, if you are calling, if you are interacting with a human, right? For example, you are calling to a customer service agent. If he or she needs to do something that takes more time, maybe you wait for a few minutes and play some music while he or she works in the background. Probably that's true if the task itself is too complicated. So I think there's a range of tasks where it is very easy to directly answer versus where it takes a few minutes to finish the task and get back to you. So I think even when interacting with a human, it's natural to have this a range of distribution of tasks and expected latency to answer.
Do you try to train that into your model? Because my intuition coming from the application development side is I just want to use two different models and I want my framework to manage that.
Yeah, I guess the thing is how do you know, right, at the runtime and inference time, whether this task is difficult or is simple, right? So if you know pre or early that these are very difficult tasks, somehow they all tranche to this specific agent, then probably you can do that. But in general, probably it will be more, I guess it will be better. You have to make that decision somewhere. So it will be easier to make it inside the model where it has all the context.
I mean, jumping off on that a little bit, any models we're using in production are not just models anymore, they're systems. And that is true of hosted models, it's true if you're hosting your own open weights models, because the inference stack is like a whole big can of worms and you're ending up writing a lot of code at that layer. The speech-to-speech model behind the API is actually not just one model, right? I think it's super useful for people building with this stuff to hear like how you think about that system.
Yeah, sure. So for the speech-to-speech, the real-time API, it actually consists of multiple models. So there was the user speaks to the API, and then there's a user transcription, which is a standalone kind of a speech-to-text model. And then the model, there's also the DAB, the model who detects the user audio activity, and then do turn detection. So these are kind of separate components. And then sometimes our customers will say why the user transcription looks wrong, or maybe in a different language, but the model still outputs reasonable output. Because there are two different models. So the transcription may be wrong, but the model really still understand the problem and then gave a reasonable answer.
Do you plan to pull the transcription into the big model envelope and not use multiple models in the future?
Probably, I guess in the near term, probably we're not going to change that. So I guess also there's a choice, right, which model you can choose. Some customers probably want to try this model, maybe some customers want to try another model because the different model have different characteristics. Some are maybe more robust in noisy situations. Some may be actually more, but at the same time may have more hallucination, while others maybe works better in team environment, but more precise to the
I mean, I like that flexibility, so I like that answer. But I also know that there's a gravitational pull to putting more and more stuff into big models, which is also good. Thank you so much for joining us tonight. It's fun to hear about how you think about the stuff you do, and congratulations on the release.
Thank you. Thank you very much.
Thank you all. It's wonderful to see you all, as always. We do these about once a month, although we're also busy. It's maybe a little more like once every 2 months these days, but if this is your first one, come back out again. And now hang out some more and eat some pizza. Thank you.